Hi folks, in the last short video I discussed with you a switching power supply topology that was in the oscillator version, I mean flyway converter. And in the flyway converter we saw that when primary winding was conducting, the secondary winding was off. Similarly, when primary winding was off, then the secondary winding was conducting. And for the energy to be transferred, we saw that the energy was stored in the ferrite core transformer using a gap, and when primary was off, that energy was delivered to the secondary side. And also we saw that normally we operate the flyway converter in the discontinuous conduction mode due to some inherent advantages like fast response to the transients and in regulation the power supply, and similarly the reverse recovery of the secondary side rectifier was none. Today I will discuss with you a switching power supply which is also the isolated version, and but it works entirely different way, and it is called the forward converter. The basic operating principle of the forward converter is the same as the linear transformer, 56-year transformer that was popular 1 or 2 decades ago. However, we know that the switching power supplies are operated well beyond above the 50 Hz or 60 Hz. I mean in the 50 kHz to 500 kHz range. The working of the forward converter transformer is entirely different from the flyway converter transformer. I mean, when in the forward transformer, when the primary winding is conducting, at the same instant the power is delivered to the output side through the secondary winding. I mean at the same instant the power is supplied to the output, and no energy stored in the ferrite core, so we don't need the gap as well. Another advantage of forward converter is that there is no buildup of the flux in the transformer core, so it doesn't get saturated, which was not possible in the flyway converter, and we had used the gap to get at this problem. However, in the forward converter, there is some impedance at high frequency to the primary winding, and so current, a small amount of current normally always flow, which has nothing to do with the secondary winding, and this current is called the magnetizing current. So magnetizing current produces some flux in the core which doesn't get cancelled. I mean, normally when primary winding is conducting, the flux is generating in one direction, and when the secondary winding is similarly at the same instant when secondary winding is conducting, due to Lenz's law, the flux is produced in the opposite direction of that of the primary winding, so the flux get cancelled out. However, as I told you that in the primary winding there is another current is also flowing, which is called the magnetizing current, and that current creates a flux which doesn't cancel out due to the secondary winding. So that flux can also saturate the transformer in the forward type of converters if we don't do some remedy for it. For that purpose, we wind on the primary winding another winding which is called the reset winding, I mean on the primary side, and the number of turns of the reset winding is also same as the primary winding. However, it can be of very thin wire, as minimum very small amount of current flows through it, I mean that of the magnetizing current. And the forward converter is operated normally slightly less than 50% duty ratio, and the rest of the period reset winding gets conducted, and the magnetizing current is reset to the initial value. So the flux, so there is a net flux in the transformer gets cancelled out. The secondary side of the forward converter consists of two diodes, an inductor and a capacitor. The output HC filter convert the ripple current to the pure DC voltage, and if we compare the configuration of the forward converter secondary side, it is identical to the buck converter, which was the isolated version of the power supply. So the design equations and the power choice and the component choice of the secondary side is the same as we saw in the buck converter. Forward converter, normally we can use the forward converter in the less than 200 watt range, and also we normally operate in those areas where the mains voltage is 110 volt AC instead of 220 volt AC, and or we use where the DC voltage is less, like in the telecom power supplies, where the DC input voltage is normally 30 to 60 volt. So forward converter, there are some variants of the forward converter other than the general scheme, and those two variants are called the single double-ended forward converter and the interleaved forward converter. This was today's short video about the forward converter, which is the isolated version of the switching power supply. And we saw that in a forward converter, the working of the transformer is entirely different from that of the flyback converter. So this was the today's short video. So stay connected, and thank you very much.